my theory of the Mandela effect and how the particle accelerator altered the weight of one electron and therefore destroyed our universe and shifted us into the universe that's directly next to it, and therefore things are different in this universe.
Right now, beneath the Alps, near the city of Geneva, Switzerland, there is a tunnel and machinery inside that tunnel.
As of this week, it has discovered 3 new particles which could help us learn how our universe was born and what its future looks like.
Have you heard of CERN? This amazing research organisation brings scientists from around the world together in Geneva, Switzerland, and they do some seriously cool stuff. They've got the biggest particle physics laboratory in the world, which they founded back in 1954 by 12 European countries to promote cooperation and advance fundamental research in nuclear physics. So what does this mean for us all? Can CERN end the world? Keep on watching this video to find out all about it. Back in 1954, Europe was still recovering from the devastation of World War II, and many of its scientific facilities have been destroyed. Their main goal is to study the fundamental structure of the universe by colliding particles together at crazy high speeds, and they're responsible for running the Large Hadron Collider, which is basically the biggest particle accelerator on the planet. If you still need clarification about that, don't worry, we'll get to it in a minute. The synchrocyclotron was CERN's first research accelerator, which began operating in 1957. At the time, it was the most powerful accelerator in the world and helped researchers study the properties of particles and their interactions. In the 1970s, CERN developed the super proton synchrotron, which produced even higher energy particle beams. Scientists used this accelerator to study the weak force, one of the 4 main fundamental forces of nature. CERN continued its advancements by constructing the Large Electron-Positron Collider in the 1980s. The LEP was used to study the electroweak force, another of the 4 fundamental forces of nature. It operated until 2000 and helped scientists make important discoveries such as the first direct observation of the Z boson. So what is the Higgs boson particle? CERN's experiments have produced groundbreaking discoveries in particle physics, one of the most significant being the discovery of the Higgs boson in 2012. This subatomic particle is a big deal because it's a crucial particle of the standard model of particle physics. Scientists have been trying to find it for years, so when they finally did, it was a major breakthrough. Now we have a much better understanding of the building blocks of the universe thanks to the work done at CERN. The Higgs boson is like a tiny particle that's created when something disturbs a special field called the Higgs field. It's believed that the Higgs field is all around us, throughout the entire universe, giving certain particles their mass. Think of it like a swimming pool full of water, just like how objects in a pool move slower and feel heavier than they would in the air. Particles that interact with the Higgs field move through molasses and become heavier, more massive particles. So, when the scientists at CERN discovered the Higgs boson in 2012, it was a big deal because it confirmed that the Higgs field exists and helps us better understand how the universe works. Now, coming to the Large Hadron Collider. A Hadron Collider is a type of particle accelerator designed to accelerate hadrons, particles made up of quarks, such as protons or ions, to very high speeds and smash them into each other. The collision of these particles produces a shower of subatomic particles which can help scientists study the fundamental properties of the matter and the forces that govern them. The largest Hadron Collider, LHC, located at CERN in Switzerland, is the most well-known Hadron Collider. This $4.5 billion tech accelerates 2 beams of protons in opposite directions, clockwise and anti-clockwise. The protons keep moving in a circular motion until they start moving at a speed close to the speed of light. This is possible because of the very powerful magnets that keep them moving, and then these particles collide at 4 points around its 27-kilometer ring. The collision produces energies high enough to temporarily create particles that don't exist in normal matter, which can help scientists study the universe's building blocks and fundamental laws of nature. When particles collide in the Large Hadron Collider, they break into even smaller particles called quarks. Quarks are highly unstable and only exist for a little fraction of a second before they decay into other particles. The sensors in the LHC record this data, which is then sent to the computers for analysis. What are your thoughts on this so far? If you're liking this video so far, don't forget to leave a big thumbs up. Now back to the video. Recently, scientists noticed something strange with a particular type of quark, the beauty or bottom quark. Normally, this quark decays into lighter particles called lepton and muon in equal proportions, but this time the data showed a 70-30 split in favour of muons. This unexpected result suggests that there may be another particle at play that we haven't discovered yet. Who knows, it might even lead to new technologies and applications that we can't even imagine yet. This interesting discovery has the potential to revolutionise our entire understanding of physics. It could completely alter the way we perceive subatomic particles and offer answers to some of the biggest unsolved questions in physics, such as the mysterious nature of dark matter. Speaking of dark matter, what we know so far is that it makes up a whopping 85% of the universe's matter, yet we still cannot see it. This is because dark matter does not interact with light or any other forms of electromagnetic radiation. However, we can detect its presence through its gravitational effects on other matter. Think of dark matter like a massive, invisible spiderweb spanning the universe. It's made up of unique particles that differ from those in ordinary matter and are much heavier. Interestingly, these particles have opposite charges to regular matter, so they are sometimes referred to as antimatter. When dark matter collides with regular matter, they completely cancel each other out. This discovery is not only fascinating, but also has the potential to unlock some of the universe's greatest mysteries. Who knows what other secrets the universe is hiding? Let's talk about this amazing discovery. Something really strange happened at CERN recently. The Large Hadron Collider, LHC, appeared to detect a crack in the Earth's magnetic field, and it remained open for almost 14 hours. This unusual event allowed some super powerful solar winds to blast through the gap, resulting in a geomagnetic storm that produced some truly epic auroras, also known as the Northern or Southern Lights. These amazing natural phenomena occurs in the Earth's polar regions and are caused by the interaction of charged particles from the Sun with our planet's magnetic field and atmosphere. So, when these charged particles from the Sun make their way towards Earth, they get caught up in the magnetic field surrounding our planet. As a result, they start to speed up and spiral along the magnetic field lines until they reach the Earth's poles. At that point, they collide with different gas molecules like oxygen and nitrogen in the upper atmosphere, creating a beautiful array of colours. What's really cool is that the colour of the auroras depends on both the type of gas that is being excited and the altitude at which the collision occurs. That's why you can see various colours from green to pink to red and even blue. A rare phenomenon caused this crack in the magnetic field called a co-rotating interaction region, CIR, from the Sun. CIRs are massive plasma structures that form in the low and mid-latitude regions of the heliosphere, which is the region surrounding the Sun that includes the solar magnetic field and the solar winds. When fast and slow-moving solar wind streams interact, they can cause a long-lasting G1 class geomagnetic storm. Despite the incredible discoveries being made at the LHC, there are some concerns and speculations from people that the experiments being performed by these scientists could eventually lead to fatal consequences. They worry that the LHC might open up a black hole that would suck the Earth in, ending all life as we know it. However, scientists assure us that the power produced by the LHC is nowhere near enough to create a black hole, and even if one were to be created, it would only be a very small one. Other concerns that the experiments might create a portal to another dimension, which could let unknown dangers creep into our world. However, some speculate this could be a doorway to a parallel universe much like ours. Are you freaked out about these discoveries? Let us know in the comments below. If you enjoyed today's video and found it interesting, then make sure to leave us a thumbs up and do not forget to subscribe to our channel and click on the bell icon to be always updated with the most exciting content as soon as it's uploaded. Thanks for watching. See you again soon in another video.